Okay, so section 12.1. And then that's when we're talking about exponents. All right. And so the first part is going to ask you to evaluate the expression. So evaluate the expression. All right, so an example would be like number 1. So if we have 4 raised to the second power, or 4 squared. Now remember, the 4 is called what's the term for 4? What do we call 4? The what? The base, good. And the 2 would be the exponent. All right, now remember what that means is that I take the base and I multiply by the exponent, I multiply by itself the exponent number of times. So that means 4 times 4, and what's the answer? 16. All right, so you would put 16 in the blank. You wouldn't put 4 times 4 in the blank, you would put 16. 4 squared means 4 times 4, which is equal to 16. Now if I had negative 4 squared, what's the base? Negative 4. Okay, because it's in parentheses. What's the exponent? 2. So that means negative 4 times negative 4, which is a positive 16. Now, there is a difference, and we mentioned that briefly last time. There's a difference between something that looks like number 2 and something that looks like this. Some students get confused with number 3. They seem to think that what's being squared is a negative 4, and that's not true. The negative is on the outside. What's being squared is only 4. 4 is the only thing being squared. So if I wanted negative 4 to be squared, then I'd have to put negative 4 inside parentheses. All right, so 4 is the only thing being squared. So if you're asked what's the base in number 3, what's the base? 4 only. 4 is the base. In number 2, what's the base? Negative 4. All right, so in number 3, you may want to just cover up that negative sign out here and just determine what 4 squared is. What's 4 squared? 16. So this becomes a negative 16. All right, and then number 4, suppose we had negative 4 cubed, and negative 4 cubes and negative 4 is in parentheses. So again, what does negative 4 cubed mean? Negative 4 times itself 3 times, and then you just use the order of operations. All I'm doing here is multiplied, and so you multiply from left to right, and so a negative 4 times a negative 4 is positive 16, and a positive 16 times a negative 4 is a, will be a negative 64. Negative 64. All right, and then finally, if you look at number 5, suppose I had this. What's the base? 4. 4. All right. Now, if I cover that negative out here, what's 4 cubed? 64. 64. Remember, 4 cubed means 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. But the answer is going to be what? Negative 64. Okay? All right, and so if you notice the difference between numbers 2 and 4. In number 2, my answer was positive, but in number 4, my answer was, or is, negative. So one of the things you got to remember is that whenever you have a negative number raised to an even power, it's always going to be what kind of number? Positive. Because a negative times a negative is a what? Positive. A negative times a negative times a negative times a negative is also a positive. But a negative number raised to an odd power is always going to be negative. So just notice the difference between 2 and 4. One was positive, the other one was negative. All right, number 6. Suppose you had 6 times 2 cubed. 6 times 2 cubed, number 6. All right, so remember the order of operations. I have 2 operations here. I have multiplication and exponent.
2 times 3 times.
you do the exponent first. So I'm going to cover the 6 up, so you're going to determine what 2 cubed is. What's 2 cubed? Yeah, so 2 cubed means 2 times 2 times 2, which is 8. And so that 8 right here is going to be multiplied by what? 6, and so what's the answer? 48. Okay? All right, so that's that first part. So that's the idea of exponents. All right, now in terms of evaluating, so part 2 is going to be evaluating an expression with given values. So here's number 2. Number 2. Okay, so number 2 is evaluate each expression. Evaluate each expression with the given replacement values. All right, so evaluate each expression with the given replacement values. All right, so let's look at, all right, so this is going to be number 14, and this on page 891. All right, so it looks like this. So my expression is this. So I want to determine what is x cubed equal to when x equals -2. So think about the previous test. So if I want to determine what that expression is equal to when x is -2, what is it that I got to do?
Turn the x into -2.
So replace, wherever you see the variable x, I got to replace it with -2. Now, whenever you're replacing a variable with a negative number, you really need to put that in parentheses. If you don't, you're probably going to mess up depending on what the exponent is. So put that in parentheses. So x cubed means in parentheses, what do I put in parentheses? But what am I doing to that -2? Cubing it. All right, and then that goes back to Roman numeral 1 that we just did. So what's the next step? Multiply -2, which is the base, by itself, how many times? 3 times. So that means -2 times -2 times -2, which is what answer? -8. Okay, good. So that was 14. 16, we have my expression this time is 4x squared. And this time, though, x is equal to 5. So 4x squared. So I want to determine what is that expression 4x squared equal to when x is 5. So wherever you see the variable x, what do I plug in? 5. Now, I would still, even though 5 is not negative, I'd still put in parentheses so you don't get confused with that 4 that's in front. So I would write this as 4 times in parentheses, what's x?
5.
And what am I doing to that 5? Square it. And again, you got to remember the order of operations. So according to the order of operations, there are 2 operations that's involved here. There's multiplication, and then there's the exponent. What do I do first? Exponent. So don't say 4 times 5 is 20 and then square it. You got to do the exponent first, and then you multiply. You had order of operations on that first test.
Would you be all right with doing 4.5?
Yeah, that's fine. You could say 4 times 5 squared. That's okay. All right, 5 squared is, and so 4 times 25 is 100. Okay? So that's 16. 18, you have, okay, so this time the expression is -4 x squared y cubed, -4 x squared y cubed, when x is 2 and y equals -1. So x is 2 and y equals negative 1. So this time your expression has two variables, x and y. So in place of x, though, I'm going to substitute what number? 2. And in place of y, I'm going to substitute negative 1. And whatever I'm substituting, put that in parentheses. So this becomes negative 4 times, in parentheses, what do I put in place of that x? 2. And what am I doing to this base 2? No, not raising the third. I'm doing what? Squaring it. Times y, and what's y? What am I doing to that negative 1? Cubing it. So all you're doing here is just plug and chug, just plugging numbers in and chugging it out. All right, but you got to remember the order of operation. So all you have here is multiplication and exponents. How many exponents do I have? But I do those before I multiply. So let's do that first exponent. What's 2 squared? So I got negative 4 times this 4 times, all right, and what's negative 1 cubed? No. Negative 1 cubed means negative 1 times negative 1 times negative 1. That's all right. Negative 1 times negative 1 is positive 1. Positive 1 times a negative 1 is a negative 1. So what is negative 1 cubed? Negative 1. And so using order of operations, what's negative 4 times a positive 4? And I'm sorry, I may have said positive 4. I meant negative 4. What's a negative 4 times a positive 4? Negative 16. And what's a negative 16 times a negative 1? Positive 16. So that was 18. And then finally number 20. And put number 20 here. Okay, number 20.
Another dumb question. Whenever, I can't see what you're writing, so I'm going by what you're saying. So I just wrote out negative 4 in parentheses 2 and then squared, negative 1 in parentheses and then cubed, so 3. Is there supposed to be a multiplication sign in between the square and the negative 1, or is that just assumed?
It's assumed.
Okay, because I know everything else is multiplied, but because there's what makes it be multiplied times one another as opposed to negative 16 minus 1?
Read this expression to me up here. Read this expression. Well, then that's one of your issues, girl. It's read negative, Angela. It's read negative 4 x squared y cubed. Okay?
Right.
All right. That means negative 4 times x squared times y cubed. There's no subtraction between any of them. It's all multiplication.
So the x and the y separation is the
Multiplication. Okay? All right. All right. Y equals negative 3. All right. So in place of y, what do you substitute? Negative 3. So I get the numerator is 10, the denominator. Now 3y squared, or 3y cubed, when I say 3y cubed, now Angela has an issue with that. What are you doing to 3 and y cubed? Multiplied. So it's 3 times, in parentheses, a negative 3 cubed, right? Okay. What's the numerator? 10. The denominator, you have multiplication and exponent. What do you do first? All right. What's negative 3 cubed? It's negative 3 times negative 3 times negative 3. Yeah, because the negative 3 times a negative 3 is a positive 9. And a positive 9 times a negative 3 is a negative 27. But that negative 27 is multiplied by what? 3. Now, if you need to, use your calculator to determine what 3 times a negative 27 is. What's 3 times a negative 27? Negative 81. All right, so you can write it as 10 divided by negative 81. But if you recall, all the fractions you've always written since you were born, and if it was negative, where was the negative located? Either on the side, or we normally put in the numerator. So in other words, you can write it, if you leave it this is fine, but we prefer to have it written either like this, or like this. Okay? All right. So negative out in front of the fraction, or write the numerator as -10. All right. And that idea is going to be important next semester when you start factoring rational expressions and then reducing. All right, and so that's all that was. Now, before we go to the next part, let me go back to that first page, and let's do a number 7 on that first page. And so here's what I want to look at. I want to look at this one. You have, in parentheses, -1/7 squared. -1/7 squared. Write the number 7 on that first part.
The square is in parentheses?
What was that?
You said -1/7 squared is all in parentheses?
No, Angela. -1/7 in parentheses
Right,
is being squared. Okay, Angela, look. Can you see it? That's how it looks. Okay? All right. What's the base? -1/7. What am I doing to that -1/7?
Multiplying times itself.
Multiplying by itself. So some of you remember when we first started this course, you had issues with multiplying fractions. Hopefully at this point you don't have those issues any longer. So you multiply the numerators. What's a -1 times a -1? What's 7 times 7? What's the answer? Positive 1/49, or 1 divided by 49. Okay? All right. So that takes care of that 12.1 part A. All right. So I think there's like one question on your test dealing with this. All right. Now, you picked up, if you haven't, you need to get this, but you picked up a sheet that has properties of exponents. It looks like this. Properties of exponents. Okay? All right, so we're going to start talking about properties of exponents. It's on one of the tables, it's up there. All right, properties of exponents. Okay, so if I have this, now listen carefully. So if I have 2, yeah. Oh, I had it enlarged it because of Angela. So let me go back and fix this. Angela, you're lucky we love you. Now I don't know how to. Let me find it. Okay, here it is. Let me go back. Angela. Angela, you need to do a little GoFundMe and say I need glasses.
Like an offering plate and everything.
Yeah.
Out, just like,
Yep.
someone will feel sorry.
I need glasses. GoFundMe fund. All right. Okay, so I think I can see it now. All right, so if I have, listen carefully, if I have 2, let me go ahead and make it a 3. So it's because I didn't want the base and the exponent to be the same. If I have 3 squared times 3 to the 4th power, okay? 3 squared times 3 to the 4th power. Now listen carefully. Now, do y'all agree that 3 squared means 3 times 3?
Yeah.
Okay, so that means 3 times 3, right here. And do y'all agree that 3 to the 4th means 3 times itself 4 times? Okay, so times 3 times 3 times 3 times 3. Okay? Now, if I use a calculator, in this part that I wrote here, and I multiplied 3 by itself, and that's how many times? How many factors? And next semester, you're going to use the word factors quite a bit. How many factors of 3 do I have here? 6. So if I say if I say on my calculator,
3 to the 6.
if I say 3 times 3 times 3 times 3 times 3 times 3, that's 6 factors, I get 729, correct?
Mhm.
Okay, 729.
It's the same thing, 9 times 81.
Yes. So what she did was she said 3 times 3 is 9, and then 3 times 3 times 3 times 3 is 81. Yes,
And 729.
729. Okay? Now, do y'all agree that if I ask you, using a calculator, find 3 to the 6th power, because that's what we said, right? It was how many factors of 6? Y'all agree that this means this, right?
Yeah.
Okay. So if I do 3 to the 6 on your calculator, you're going to say 3, and remember you're going to use that thing that looks like a roof, exponent 6 equal, and you get 729, correct? Okay. Now, go back to this problem here, and notice what's this base right here that I'm circling? 3. What's the exponent? 6. Go back to the original problem. What is the base that you see? 3. How can I get 6 from those exponents? You add them up. So the idea is this: if you're multiplying exponents, exponential expressions, and the bases are the same, you add the exponents. That's called the product rule. That's this right here, that first rule. So you see where I have 3 to the 5th times 3 to the 7th, that example? Then that's just 3 to the what? 5 plus 7. So in words, the product rule says this. Okay, product rule says this. If you multiply like bases, and this is only true, the product rule only applies if the bases are what? The same. If one was a 3 and the other one's a 5, you couldn't do that. You wouldn't say 3 times 5 is 15. You don't do that. Okay, so the product rule, if you multiply like bases, you add exponents. All right. So in what we just did, that 3 to the 2nd power times 3 to the 4th power, then that's 3 to the 2 plus 4, which is 3 to the what? 6. And so the rule, if you look at the rule in terms of letters, it basically says this. A to the m power times a to the n power is just a to what power? M plus n. Not mn, m plus n. And that's all it says. Okay, so that's your product rule. All right, so let's see how we're going to use that product rule. So here's some examples. So if you look at your study guide, okay, so if you look at your study guide, that's going to be on that second page right here that I told you to cross this out. That's going to be 12.1 Part B. So 12.1 Part B is the one that deals with the product rule. Okay? It's very simple. It's a simple rule to use. But that's going to be your product rule right here. That's the product rule. Yes.
Cross A out.
Yeah, you came in late. Yes. Cross A out. All right. Okay, so here's some examples. All right, guys, y'all got to... so towards the end of the semester, I was going to say, y'all got to make sure y'all come in class on time, but towards the end of the semester, it's not going to matter anymore. All right. So let's do this example. This is going to be number 22. Number 22. And that's on page 891. Same section. You have something that looks like this. Okay? Y squared times y. Now, if there's no exponent, what is it understood to be? 1. So the rest is going to say simplify the expression. So simplify means make it simpler. Make it simpler. Using properties or using things that you've learned. So what property am I going to use in number 22? Product rule. So I have y squared times y, so I'm multiplying like basis. So I do those exponents. Add them up, and then you can just say the answer. What's the answer? Y to the third. That's the answer. All right, so that's 22. 24. You have negative 5 to the 7th times negative 5 to the 6th. All right, so all I want you to do is just simplify this. Don't use your calculator at all. Just simplify this. Can I use the product rule?
Yes.
Why can I use the product rule? Because the bases are the same. So since the bases are the same, it's going to be the base raised to the sum of those exponents. So the answer is going to be what? In parentheses, right? Okay. Raised to what power? 13. All right, so that's 24.
So it doesn't affect it that it's negative 5 times negative 5, that wouldn't change anything positive.
No.
It's still gonna say, I just,
All right, 26. You got to listen carefully to this part. You have negative 2z cubed times negative 2z squared. Okay, now distinguish the coefficients. In that first parentheses, what's the coefficient? Negative 2. In the second parentheses, what's the coefficient? All right, so all you got to do is just multiply those coefficients. So if that second parentheses was a 5 for the coefficient, then you'd say negative 2 times 5 is a positive 10, right? All right. So first thing you do is use is multiply the coefficients. What's a negative 2 times a negative 2? Positive 4. And now I use the product rule on the bases. What are the bases? Z. So when you multiply like bases, you do it to those exponents. So what's the answer? 4z to the 5th power. 4z to the 5th. Okay, 28. You have a squared b times a to the 13th b to the 17th. All right. Multiply like bases, you add exponents, product rule.
A to the 15th.
A to the 15th, because if you look at the a's first, a squared times a to the 13th is a to the 15th, and then b to what power? B to the 18th. So the answer is, and we tend to put it alphabetically. If you put the b first, no big deal, but we talked about the fact that we tend to write things alphabetically. So a to the 15th, b to the 18th. So here's your answer. 30. It is not difficult. All right, negative 7 a cubed b cubed times 7 a to the 19th times b. So now notice, now in number 20 you had coefficients also. What was the coefficient of a squared b? 1. There was nothing there, so understood to be a 1 in front. Remember that? All right, and 1 times 1 is 1, but we tend to not put the 1. Here I do have coefficients other than 1. What's this coefficient here? What's the coefficient here? So this says I multiply. So what's in terms of the answer, what's the coefficient? Negative 49. Okay, now tell me the rest. A to the 22nd, because I add exponents, 3 plus 19 is 22. And then B to the 4th, very good. All right, 32. All right, 32, you have 12 x to the 5th times negative x to the 6th times x to the 4th. Okay, so let's talk about the coefficients first. But we have 12x to the 5th, negative x to the 6th, and an x to the 4th. In that first parentheses, what's the coefficient? 12. In the second parentheses, what's the coefficient? Negative 1. Good. In the third parentheses, what's the coefficient? 1. So it's 12 times a negative 1 times 1. Negative 12. Okay. And then the only variable for your base is x. So it's x to the 5th times x to the 6th times x to the 4th. X to the 15. Yep, so the answer is negative 12x to the 15th power.
You said it's okay if we put the dots instead of the parentheses to multiply.
You mean put dots right here?
Like for up there, like how in 24 you put a dot in between them.
Yeah, that's fine.
Okay.
Yeah. Okay, so let me make sure on that part. Yeah, so that's, let's do one more with this. So write this example. Okay, I have 1/3 y to the 3rd power times 12 y to the 6th power. So 1/3 y to the 3rd power times 12 y to the 6th power. All right, what's the coefficient of the first one? 1/3. Coefficient of the second? 12. Okay. So you're saying 1/3 times 12, right? What's 1/3 times 12? 4. Good. So my answer is going to be 4, what? Y to the 9th. All right, and so that's all that part was. So part B, you can now do. That's part B. Okay? All right. Okay, so that's the product rule. Let's talk now about let's talk about this. Before we even mention what proper we're going to talk about next, let's look at an example. All right, so this is, suppose I had this. Okay, suppose I had this. Suppose I had 2 cubed, and that was being raised to the 2nd power. Yeah. 2 cubes in parentheses, and that's being raised to the 2nd. Okay? Oh, hold on. Don't say anything just said.
Getting a little cheeky now.
So this time 2 cubed is both in parentheses.
2 cubed is in parentheses.
Raised to the 2nd power.
Is raised to the 2nd power. Okay, so let's talk about that parentheses first. Okay? So I'm going to ask you, in terms of this expression, what is the base? 2 cubed is the base. 2 cubed is the base. In terms of that expression here, your outer exponent is what? The outer. 2. So what's inside the parentheses is going to be the base. So my base is 2 cubed, right? Okay. So remember, I take the base and I multiply by itself the exponent number of times. What's the exponent? 2. No, the exponent's 2. I'm circling it, okay? Okay, so that's my exponents. That means that this is your base. So 2 cubed times what? 2 cubed. All right, now think about the product rule. I can use the product rule here. What's 2 cubed times 2 cubed? Gee, why did I say 4? You didn't do that in the earlier problems. You don't multiply the bases. it's 2 to the 6, right? You keep the base. So it's 2 to the 6. Y'all agree?
Yeah.
All right, now let's go back and look at our original problem. How can I get 6 from those 2 exponents that you see? Multiply them. So when you have a power raised to a power, you multiply exponents. Power raised to power, you multiply exponents. So z cubed squared is, I didn't mean z, 2. 2 cubed squared is 2 to the 6th power. 3 times 2 is 6. So don't do it the long way like I did. Don't change it back to using the product rule, because that could have been this. I could have had 2 cubed to the 200th power. You'd have had to write 2 cubed how many times? 200. You don't want to do that.
So why couldn't you just do 2 cubed and you get 8, and then you do 8 squared and you get 64, which is the same thing?
Because you want to leave it as the base 2. You want to write it as, you want to leave it the base 2.
So you can't, are you going to come out with the same answer every time if you do it the way I did it?
But Angela, the what's going to happen? See, I use a nice number with I use the 2 cubed with a 2, right? We're going to have variables in a little while. So if that was z cubed, what would you do? It was z cubed. Guys, if that was z cubed squared, what's the answer?
Z to the 6.
Z to the 6. You leave it in exponential form.
Right, I understand.
Okay. So 2 cubed to the 200 is 2 to what power? 600. So when you have a power raised to power raised to power, you do what to those exponents?
You just
Multiply.
All you have to do.
Yes.
That's it.
So that's called the power rule for exponents. Power
You're saying
rule.
don't multiply them. Okay. So
Don't
like,
multiply them.
another
Leave the
word,
base as the base, okay?
That'd be 2 to the 200th.
2 to the... Now, Angela, if you want to go ahead and you want to say 2 to 600, I'll take your calculator away. If you want to say 2 to 600, you can go...
I'm not talking about this. I'm just making up something. I'm just saying, instead of taking 2 to the 200th and multiplying it out,
Leave it as 2 to
the
the
answer is
200.
2 to the
Leave it as 2 to the
200.
200. Okay? Okay, so this is called the power rule for exponents. All right, so the power rule for exponents says this. If I have a to the m power, and that's being raised to the n power, then what do I do to those powers, to those exponents? Multiply them. So that's going to be a to the m times what? N. All right, so that's the power rule. So when you have a power raised to power, you multiply them. Okay? All right, so let's do the examples. So that part's easy. So watch what happens, though. That part's easy. So look at this. So this is 36. Y to the 7th raised to the 5th. What's that equal to?
Y to the 35th.
Y to the 35th. Okay, no big deal, right? So that was a product rule. I'm sorry, that was a power rule. That's all the power rule is. Now, worksheet C, though, extends this idea. So listen carefully to what I'm about to say. Listen carefully to what I'm about to say. Suppose I had this. Suppose I had 2 cubed times 3 squared, all that's in parentheses, raised to the 3rd power. Okay, just watch what I'm doing. Angela, just watch what I'm doing, okay? So 2 cubed times 3 squared, all raised to the 3rd power. Now, remember that the outer exponent is what? The outer exponent is what number? 3. So that says I take what's inside the parentheses and I multiply by itself how many times? 3 times. Okay, so that means this. 2 cubed, 3 squared, times 2 cubed, 3 squared, times 2 cubed, 3 squared, right? And so now I'm going to use the product rule that we learned a while ago. The product rule. 2 cubed times 2 cubed times 2 cubed is 2 to what power?
9.
The 9th. 3 squared times 3 squared times 3 squared is 3 to what power? The 6, right? Okay. Now, I want you to think about this. How can I get that 9, exponent 9, from the original problem? 3 times 3. So it's kind of like that power rule again, right? Okay. How can I get that 6? 3 times 2. So basically you're saying this. I'm going to cover this up. Watch my finger. You're basically saying 2 cubed raised to our power. The third, and then you're saying, I'm going to cover this one up now, 3 squared raised to our power. The third. So here's the idea. In your mind, you're saying 2 cubed raised to the third times 3 squared raised to the what? The third. And so notice each one is the power rule. A power is a power. You do what? Multiply. So that's 2 to the 9th, and that's 3 to what? 6. Okay, now, this is called power to a power rule. And your book calls it, I think it's on the next page, it's called the power product rule. Your book calls it a power product rule. So power, now listen, and here's why it's called that. Power of a product. Okay, so here's why it's called power of a product. Makes sense. In this parentheses I have here that I'm pointing to, inside the parentheses I have a what? What am I doing to those two things? Multiply. I have a product, right? And what am I doing to this product? Raising it to a what? A power. So hence a power of a what? Product. And all it says is this. Take each factor and raise it to the power, like I did here. So it'll be 2 cubed to the third, and then 3 squared raised to what? The third. And so in notation form, it looks like this. I'm just using what the notation they have here. A, B raised to the n power. See that? That says I take the first factor, which is A, and I raise it to what? The n. And I take the second factor, which is what? B, and I raise it to the n. So that's what this says. A to the n, B to the n. So when you have a product inside the parentheses, you take each part and raise it to the what? The outside power. Okay? Now watch how simple this is. So this is going to be number 40. Now listen to the words when I do number 40. Got to listen to those words. 4 Exodus 6 squared. 4 Exodus 6 squared. Students that try and skip a step with something like this mess up with part of it. They want to say that the answer is 4x to the 12th. That's not quite correct. Think what we did. In parentheses, I have a product, right? My factors are 4 and Exodus 6. What do I do to each of those factors? Raise it to the second, are the words I wanted you to say. Okay? Raise it to the second power. So in your mind, this is what you're saying. You're saying 4 what? That's 2. Where are you getting 3 from? That's 2. 4 squared times Exodus 6 what? Squared. And now you use the power rule. First of all, what's 4 squared? 16. What's x to the 6 squared? X to the 12. There's your answer. So what they mess up on is that coefficient. So you got to always remember, if you see if the coefficient is other than 1, you got to be careful. It's 4 raised to the outside exponent. So 4 squared is 16. Okay? All right, so that's 40. Let's look at 42 now.
How are you writing that down as an answer? Like the last
16
answer?
x to the 12th. I'm underlining what you're supposed to write. 16 x to the 12th. Okay?
You just write, like the last answer was 2 to the 9th and 3 to the 6th. There's no commas or parentheses or anything. You just
No,
write it
Angela,
down.
it's multiplication. Just like this is multiplication. 16 times x to the 12th.
The answer is written.
2 to the 9th times 3 to the
So
6th.
you put a multiplication in between the 2 to the 9th and 3 to the 6th.
That's because the original problem was a multiplication, Angela.
I just asked.
So 4 times x to the 6.
Right.
So 4 to the second power times x to the second power. So, x to the 6 to the second
You
power.
leave it like that. You don't try to work it any further.
No, what would you do? There's nothing you can do any further. I mean, the variable's x.
I
Okay?
was trying to figure that out.
So the answer is just 16x to the 12th. I think you're trying to put too much into this. You're trying to overanalyze something. 42. A to the 4th power, B all raised to the 7th. Now I'm going to ask you this question. What property do you see that you have to use? That is not a property we wrote down, Linda. Power of power of product rule. Power of product rule. I have a product inside the parentheses, right? A to the 4th times, hence the word product, what? B. And that product is being raised to a power. So hence power of a product. Power of a what? Product.
So is it 8 to the 28th, B to the 7th? Or?
Yep. No, you're right. See, you're trying to overanalyze stuff, and just don't do that. You're making it too difficult for yourself. So the power of product says then I take each part of that product and I raise it to the outside power. So in your mind, this is really a to the 4th raised to a power, 7. And this is really b to the 1st raised to a power, 7. And then you use the power rule now. So this is the power rule. So remember the power rule. You have a power raised to power. You do what are those powers? Exponents? You multiply them. So what's the answer? 28, b to the 7. Okay? All right, Angela, there's nothing else you can do. Just leave it like that, just like you said.
So there's no dot, or when I put it just like that, your assumption is multiplication.
You're to assume that it's multiplication. Okay? If there's no dot there, it's understood to be multiplication. If it's another operation, if this was plus, you see the symbol plus. Minus, you see the symbol minus. Division, you see the symbol division. If there's no operation there, it's understood to be multiplication. Okay? All right, look at 44. You have negative 3, x to the 7th, y, z squared, all raised to the 3rd. Right in that next step. Don't try and do too much in your head. Okay? So inside the parentheses, I have a product. All that's product inside the parentheses. And in how many factors do you see inside the parentheses? Give me the first factor that you see. Negative 3. Very good. Negative 3. I'm putting that in parentheses. It has to be raised to what power? The 3rd. Very good. What's the next factor that you see?
X to the 7th.
It has to be raised to what power? The 3rd. What's the next factor you see? Y. It has to be raised to the what? The 3rd. What's the next factor you see?
Z to the 2nd.
It has to be raised to what power?
3rd.
All right. And then once you write it like that, then you got the answer. What's negative 3 to the third, though?
-9.
Now, negative 9, negative 27. It's negative,
Oh, so you
negative. Angela, you don't.
confused.
We talked earlier, Angela, about
But-
4 squared. Does 4 squared mean 8, or does
No,
4
I
squared mean 4
understand
times
that,
4?
But okay, so when you get to x to the 7th, though, you're multiplying it times 3, which is x to the 21st, not x times 7 times
But what is this
7.
exponent over here understood to be? That's a 1 right here, negative 3 to the first power. She's trying to make that an exponent.
I'm just confused why you're multiplying, why you're cubing one, and then the other one you're multiplying it times itself, not itself, but.
Well, Angela, but if you look at this, I mean, you are multiplying by itself. X to the 7 times X to the 7 times X to the 7th, right? But X to the 7 times X to the 7 times X to the 7 is X to the 21st. What I did here was use the product rule. But then the next rule we saw, Angela, hold on, Angela, hold on. Then the next rule we talked about was the product.
I know all the rules you talked about.
Okay,
I'm
so
just
what-
confused why doesn't the same rule apply for -3 as it does for x?
It does apply. What's X to the 7 cubed means X to the 7 times X to the 7 times X to the 7, correct? Which is X to the 21st, right? So here the exponent's a 7, though. Angela, do you agree the exponent here is a 7?
Correct.
When you have a power, it's a power. What do those powers? When you answer me,
You
multiply. Okay, what's that exponent right here for negative 3? What's that exponent? There's no exponent there. What's it understood to be?
for
1.
-3?
Negative 3 to the first. It's being raised to the third power. 1 times 3 is 3. So that's negative 3 to the third. Negative 3 to the third means negative 3 times negative 3 times negative 3. That was Roman numeral 1. Were you here when we talked about Roman numeral 1? Or did you come in after that fact?
Obviously, yes.
Okay.
I mean, I'm gonna do it like this, I just don't understand the concept, but I mean, I'll do it.
Negative 3
I understand
is a
what you're
coefficient. When we
saying.
talked about coefficients, negative 3 is a coefficient, right? What am I doing to that coefficient, Angela? I'm raising to what power?
So you're cubing it.
I'm cubing it. What does that mean, negative 3 to the third power, Angela?
That means -3 times -3
Times negative 3, right.
Why isn't x times to the 7th power? Why do you do those differently?
You can. X to the 7th power cubed is X to the 7 times X to the 7 times X to the 7.
Okay, so what's the answer?
X to the 21st.
But that's not x to the 7 times 7 times 7 is not 20.
You're not saying 7 times 7 times 7. That's your exponent.
So you're not cubing it then.
X to the 7 times X to the 7 times X to the 7 is what, Angela?
I would say 7 times 7 is 49, and 49 times 7 is.
When I'm using the product rule, what's the product rule say? When you multiply like base, you do what to those exponents?
I know
You say you know, but you don't, because you said 7 times 7 times 7. You don't.
You just asked.
You
me
add
what
them.
7 cubed is. 7 cubed is 7 times 7 times.
I'm not saying 7 cubed. I'm saying X to the 7th cubed. This is not 7 cubed. That's X to the 7th cubed.
But why do you cube 3?
I'm cubing all of these. X to the 7th is being cubed. Y is being cubed. Z squared is being cubed. Negative 3 is being cubed. They're all being cubed.
Did you say so? Okay. I just don't see it the way you're seeing it. I'm sorry.
Okay.
I mean, I'm going to do it this way. I just don't
all right.
see it that way.
Okay.
I
I'm just
understand
running
how
out of
it-
time here.
Well, I understand how to do it now.
okay.
It doesn't
All right.
make
So
sense.
negative 3 cubed means what, guys?
I know, but it's.
Negative 3 cubed means what? What is it, though? Negative 27. X to the 7 cubed means what? 21st. Y to the first cube means what? Y cubed. Z squared cube means what? Z to 6. There's your answer. All right, that's all I can do with this. I ran out of time with that part. So, but I think you have enough information to be able to do the worksheet. Okay? All right, so that was 44. All right, now, we still have a part on your study guide. Okay, so we talked about this. So this is the power of a product. That part C. Part D, we're going to do next class period because we got to look at something else. Part D is where we're going to use something called the quotient rule. So we're going to do that in the next class period. It is on your test, all right? It is on your test. So this is the quotient rule. All right, now listen carefully what we're going to do now. We're going to go to the next one that you see here. Find an equation of a line with the given slope that passes through the given point. And you're going to write the equation in slope-intercept form. All right, so look at that one. And then the other one we're going to probably do that for next class period because we only have 15 minutes left. The next one is going to be find an equation of the line through a pair of points. All right, so let's talk about those two things. All right, so I'm going to